you're going to be hearing 12 presentations from our contestants from these 4 labs. I want to point out, though, that their journey coming here or getting here has been a rather long one. They've spent countless hours preparing their talks, practicing them. They've attended seminars and workshops to help refine their talks. In addition, they've gone through multiple levels of, or multiple competitions at their home lab as well, just to get here today. In addition to this competition, what I really want to highlight is that this long journey actually provides a really great opportunity for our postdocs and our early career staff at the labs to really focus in on their communication skills and to get comfortable presenting their work in a large audience. So for those of you in the audience that may have started your own research career a long time ago, like myself, you may remember that when we first started out, the main emphasis really was to embed yourself in your research and to learn all the technical details that you needed in order to advance the science. And communication skills is something that many of us were expected to learn along the way over many years of trial and error. And some of us are still perfecting it, myself included, of course. But competitions like this, like Research Slam, really provide an excellent opportunity for our early career staff to really expose them to that and to develop their skills in a way that they can really go out and communicate what they're working on and why it's important. And I think after we hear these presentations today, I'm pretty confident you all will agree that all the hours and time that our contestants have invested in coming here today is certainly well worth it. So with that, I encourage you to sit back, relax, and get ready to enjoy the show. Before we do that, though, I'd like to take a minute to introduce our MC for this afternoon, which is Kasha Patel. Kasha is a stand-up comedian and writer based in the Washington, D.C. area. She focuses on jokes that are related to science. She holds a degree in chemistry from Wake Forest College and also a master's degree in science journalism from Boston University. She's earned several awards from NASA for her science communication work and has been featured in the Washington Post, BBC World News, the Science Channel, as well as the Weather Channel. And so that was something new to me. I didn't realize that there were a lot of jokes on the Weather Channel, so I have to go back and check that out. She also, just a couple years ago, gave a very interesting TEDx talk titled Sneaking Science into Stand-Up, where she shares a lot of her surprising results that she found by analyzing over 500 of the jokes that she's put together. So I'd encourage you, if you haven't seen that, check it out. It's really fun to watch. So please join me in a warm welcome for our MC, Kasha Patel.
Thank you. All right, there we go. Thank you so much, Eric. Thank you for that wonderful introduction. You said it exactly as I typed it for you. Thank you. I am so excited to be here. Clap it up for the nerdiest competition since BattleBot. Yeah. I think it's so cool that Berkeley brought rally towels. Let's spin those things. You know they don't have a football team. They waited all year just for that moment. We know who they're supporting. Oh, boy. I'm so excited to be here. Hi to the people on WebEx. We have a good contingent on there. I know it might be weird to see a pitch slam, a research slam on Zoom or some kind of virtual thing, but trust me, there are a lot weirder things that you can do on Zoom. My best friend in the world actually got married on Zoom. Yeah, it was extremely lame. It was BYOB. Bring your own bandwidth. And she didn't even upgrade it, so it cut off after 40 minutes. So I didn't even get to stay for the dancing. It was a very budget wedding. Like Eric said, I'm your MC. My name is Kasha Patel. It is a foreign name. And I always think foreign names always have the prettiest meanings. Like my mom's name is Shobha, which literally means beauty. My brother's name is Covey, which means poet. I found out that my name, Kasha, also has a meaning. It is a type of buckwheat. My ex-boyfriend actually found that out and had to break up with me. He was gluten-free. Someone actually came up to me after I said that, and they said, Kasha, you know buckwheat is already gluten-free. I was like, first off, nerd, am I right? And second of all, oh my gosh, that breakup was way worse than I thought it was. I'm very excited to go over what we're going to be doing today. This is today's schedule. It's quick. Like Eric said, we have our 12 finalists over there nervously tapping their feet, so we see that. It's going to be a 3-minute talk, which means that in the time you've already listened to me and Eric, you will have heard at least 2 of them by now. We're going to have some audience trivia, see how much you actually know about the labs, and you'll win some nice prizes. And then we're going to send the judges away to either crush or make these young contestants' futures. And then we have the People's Choice Award, and then the winners will be announced, and then we'll have reception, social hour, food. We can, all right, so now I do want to know, I know that there is a little bit of a disadvantage with the local crew here, and then some people brought rally towels, but I want to hear who exactly we have out here. So clap it up or cheer for Berkeley Lab. All right, that's pretty strong. Clap it up for Lawrence Livermore. Sandia Lab. Small but mighty is what they say. And SLAC. Smaller and even mightier, they would say. So what are these contestants competing for? These are our awards and bragging rights and an update to their LinkedIn profile. We're going to be awarding first place, second place, People's Choice Award, and then we have a team award out of the 3 contestants who earn the most points for their lab. They get to take home this trophy over here for 1 year. It's just like the Super Bowl. The rules of the competition. So their judges are going to score them based off of 6 criteria. Some of you might know this. I know we have some past competitors in the crowd. But we're going to see how significant is their research. Is their contribution clearly specified? Is the way that they presented it clear and logical and makes sense? What is their delivery and stage presence like? And the presentation of their background or the context that they put it in, and the ability to entertain you and keep your attention. They have only one slide, no animations, but there is no limit to text on there, so we'll see what happens. And they must not exceed 3 minutes. If they do, they will get docked, and there's no warning for them, so they just have to hope that they time themselves enough before this. Now let's introduce our sharks in the Shark Tank, also known as our distinguished judges. Please give it up from the Department of Energy, Azmaret Asafal Burhe. Your own Lawrence Livermore, Pat Falcone. From Sandia National Labs, Andy McElroy. Lab Director of SLAC, Chi-Cheng Kao. And last but definitely not least, from Berkeley Lab, Mike Witherall. All right, now without further ado, let's get this party started. We're going to start with our very first contestant. I'm very excited to welcome David Couch for his presentation on gas phase chemical physics, peering into the smoke, one reaction at a time. Give it up for David Couch.
We are no strangers to fires, right? even before the pandemic, how many of you already had a face mask to protect you from the smoke? How many of you remember the sky turning orange last year? This smoke can be really scary and very annoying, but it's actually the product of one of nature's most fascinating chemical reactions. Each smoke particle is composed of a intricately formed carbon structure. And I'll tell you a secret. We chemists still don't really understand how these structures form so quickly. Now let me clarify. Chemists from all over the world have built these computer simulations that account for thousands of reactions that take place all simultaneously in a fire. And the simulations do really well at predicting small molecules with just a few carbon atoms. But they underpredict the bigger molecules, and especially the really big ones that make us cough. So what's wrong with our simulations? Well, the main problem is there's a lot happening in a fire. And so it's really hard to figure out whether the simulations are correctly accounting for the role of each individual reaction. So what we wanted to do is simplify the problem by reducing the number of reactions at play. So here at Sandia, I built a special reactor that gets really hot, but it doesn't use a fire. It's filled with helium, because helium is the least reactive element. It doesn't react with anything. So I fill it 99.9% helium with just a tiny bit of room for the two molecules I want to react. And then I can study one reaction at a time how these carbon structures actually form. This way, we can experimentally determine what our simulations might be missing. And in addition to improving those simulations, we're also learning how we can use computers to better predict these reactions so that we don't have to study every single one. Now, you might be wondering, why do we need to know how smoke forms? Mostly we just don't want any, right? Well, you'll be hearing about how to stop smoke from forming from another Sandia postdoc later today. But we're not just interested in smoke. There are some very useful materials that are also made from intricately formed carbon structures. These carbon nanomaterials are already being used to improve batteries, solar panels, medical devices, many other possible applications. But they're very expensive because they're hard to produce. And it turns out one of the most promising ways to make them is very similar to the conditions that make smoke in a fire. So if we can understand how nature makes these structures so quickly, we can harness that chemistry to steer these reactions toward the products that we actually want. So the next time a wildfire blows smoke through your neighborhood, think about how much fascinating chemistry is getting stuck in your face mask. And remember that my team is trying to turn a major hazard into a major benefit. We didn't start the fire, but maybe we can use it to make the next generation of materials. Thank you.
Fantastic job. It's always incredible when you guys talk about fires here. I'm in Washington, D.C., and everyone always goes crazy when they see the sunset extra orange. Then I work in the weather desk, and we have to say, that's not a good thing. That's not a good thing, that's a smoke. Also, David was correct when he said that helium doesn't react to anything. It never reacts to any of my jokes. Thank you. Thank you. That was also a bad joke. All right, so we have some trivia that we're going to be doing. Maybe some of the Sandia crowd will know this, but I'm going to ask it, and then if you know it, raise your hand or shout it out or whatever. Oh, okay. Well, all right, you're jumping the gun. All right, at which Hawaiian island does Sandia have a launch facility? Hawaii. All right, so say it one more time. Say, did you want to say it? Kauai. That is, drum roll, please. Correct. We do have a sweet treat being brought to you as we speak. The Kauai Test Facility is a rocket launch range in Hawaii. The facilities and personnel support a variety of missions. This is not that helpful of a slide in terms of what they do. But I do need to ask, Andy, have you been there?
I drove past on vacation.
Wow. Well, I vote that next year we have the slam there. There we go. All right, I'm excited to introduce your next contestant. Oh, yes, I did forget to say that as our judges are going to be deliberating at the end of each presentation, they will be writing their scores down. And I did forget to ask them, how am I doing so far? Oh, wonderful. We have our emoji voting for me. Oh, I got a winky face, which is very suggestive. Thank you. Nice is what it said on the back. All right, I'm excited to introduce your next competitor. He will be talking from Earth and Environmental Sciences, From Survive to Thrive, A Story of Resilience. Please give it up for Mohammed Obadi.
Have you ever wondered how rainfall makes its way from clouds up in the sky to the fast-flowing rivers of Earth? Well, the slope of the Earth's surface shapes areas that collect rainfall and direct it to a single point in a river. These areas can be as small as a football field and as large as covering half of the United States. We call them hydrologic catchments. And they are precisely what I want to talk to you about today. But before that, let's talk about us, humans. Every one of us is a walking story of resilience, surviving in the face of illness, emotional shocks, financial difficulties, public speaking. Over the course of our lifetimes, we encounter those adversities over and over again, inviting us to think, what makes some of us better than others at handling difficulties? Why some of us recover quickly while others don't? Now, hydrologic catchments, as big and massive and different from humans as they are, they also experience adversities. These are in the form of floods, droughts, heat waves, and wildfires. And there are emerging evidences that just like humans, the response of these systems can be quite distinct. Some catchments bounce back following disturbances, while others might not recover at all. It is puzzling. Now, prior research relied on numerical models, which serve only as an approximate representation of the natural system. So in order to overcome this limitation, my team and I utilize modern techniques of machine learning, which allows us to learn directly from observations without imposing any assumptions on how the system might work. By doing so, we are able to identify the key factors responsible for the behavior of hydrologic catchments, thereby helping decision makers answer key questions, such as whether to build a dam, plant a forest, how to manage groundwater during droughts, and so many other questions. As the global climate continues to change, threatening our freshwater resources, these are the questions that we need to answer in order to make sure that hydrologic catchments always recover following disturbances, surviving, thriving, and providing us with fresh water for many generations to come. Thank you.
Wonderful job. I also didn't realize you can also do AV effects during your presentation. I also like his song choice where he's getting all of you to clap. There's much more than just this on the slide. It's all about presentation. Good job, Mohammed. We can clap it up. All right, our next trivia question, let's really test how well you know Berkeley Lab. We have so many of you, maybe someone will know this. How many elements have been discovered at Berkeley Lab? 14. We heard of 14. Any other takers? 5. Very much doesn't have faith in Berkeley Lab. 5, 14, yep. 3, okay, 3, 14. We can keep going. No one got it right yet. 15. What was that? 1, 6? 1, 6, 16, and the answer is 16. Congratulations. Did you actually know that?
Actually, I just passed by the lobby of Berkeley lab.
Okay. Oh, so you were just like calling on your photographic memory while they all got it wrong. You're like trying to count them. So can you name all 16?
I did, but actually, they have written names, like named by Curry or Berkeley here in California.
I think if you can name all 16 in less than 30 seconds, you can win the trophy forever. I think that would be fine. All right, I'm ready for our next wonderful contestant. Her presentation is in the Materials Engineering Division. It's invisible organ on a chip, and I have a gut feeling this will be good. You guys don't get that joke yet, but you will. Please give it up for Lindy Jang.
Did you know that we are more microbial than human? The human body consists of trillions of microbes that outnumber the human cells. So it's not surprising that the microbes dictate our overall health and that they're called as an invisible organ of humans. The majority of the microbes reside in our gut. They digest our foods, regulate the immune system, and protect us from diseases. However, the imbalance between the good and bad microbes may lead to diseases like traveler's diarrhea. That's why many people get sick when they drink tap water full of new microbes while they're traveling in a foreign region. There are also multi-drug resistance, inflammatory bowel disease, depression, anxiety, diabetes, cancers, and many more. For most diseases, it's unclear to which extent the imbalance between the good and bad microbes is the cause or the consequence of the disease. It's also nearly impossible to study the microbial composition inside the human gut, since it's significantly different when it comes out as species. Therefore, we wanted to engineer a human gut that can directly analyze the individual contributors to the disease. The human intestine is composed of the villi that protrude out like fingers and crypts that look like deep pockets in between the fingers. I used 3D microbioprinting techniques to recreate the crypt villi structure using soft hydrogels. I succeeded in printing the villi and crypts that are 3 times the width of the human hair. We cultured human intestinal cells on top of the villi and crypts and assembled this intestinal tissue into the co-chamber system that we developed, where the upper chamber is for the anaerobic gut microbes and the lower chamber is for providing oxygen and foods to the cells. We can easily control the types and the numbers of the microbes of interest, which is one of the huge benefits of our in vitro system over any human trials or animal studies. This invisible organ in a chip that we can hold in our hands recapitulates the living ecosystem of the human gut. By using patient-specific cells and intestinal geometry, we can develop personalized medicine. We can sort out the good microbes and use them to fight the bad ones. We can do all kinds of drug testing, especially the chemotherapeutic agents, which are known to be very destructive to the microbial community. It can also be used as a dietary screening device, testing foods like peaches or tomatoes to determine if they are good or bad to you. Last but not least, many diseases can be prevented by achieving deeper understanding to the cause of some disease development. What I have listed is just the tip of the iceberg. There could be countless applications using this invisible organ in a chip that can save millions of people's lives. Thank you.
Very, very impressive. I do not feel smart enough to be on this stage right now. All right, our next trivia question. Who founded the town of Livermore? What was the answer? Robert Livermore? Do we have any other answers? Is that your final answer? Did you just Google that? It felt like you just Googled that. The answer is William Mendel Hall. Congratulations. And yes, he did name it after Robert Livermore, who is also known as Don Roberto Livermore. All right, I'm excited for our next presentation. This is in Fundamental Physics Directorate. It's called Not So Elementary, My Dear Watson. Please give it up for Amol Patwardhan.
I want to start by asking you all to take a deep breath. Now think about the oxygen you just inhaled. What if I told you that every single atom of oxygen that anyone has ever breathed in came from the bowels of a dying star? How does that work? Well, it so happens that massive stars, much heavier than our sun, get to a stage where their inner core becomes so heavy that it literally collapses under its own weight. This sets off a chain of events that culminates in the star blowing itself to smithereens. These explosions, called supernovae, are so bright that they can briefly outshine the entire galaxy where they reside. And yet, the fascinating part of this is that most of the energy that's put out in these explosions is actually invisible. Crazy, right? What happens is that most of the explosion energy goes into these particles called neutrinos. Now, neutrinos, they are unlike any other particles that we know. They don't have a charge, they almost don't have a mass, and they don't interact very much. So they're introverts, kind of like me. But in large numbers, they can still pack quite a punch. These neutrinos are, in fact, the main driving force behind these supernova explosions. And they also regulate the conditions for the synthesis of elements in supernovae. Now, we know well enough that supernovae can make the oxygen that we breathe. But for heavier elements, the picture is not so clear. So that's where my research comes in. You see, these neutrinos, they have another peculiar property. They come in multiple flavors, like ice cream. So let's call these flavors chocolate, vanilla, and strawberry. But here's the thing. Suppose you buy a chocolate ice cream, and you look at it again a few minutes later. It's still chocolate, right? But neutrinos don't work like that. So you could make a chocolate-flavored neutrino, but you give it some time, and it may start looking like a vanilla-flavored neutrino. So these flavor changes of neutrinos, called neutrino oscillations, can have a profound impact on the way in which the elements are synthesized. And that is because the different neutrino flavors interact with matter in different ways. So my research then is about understanding the details of these flavor oscillations in a supernova environment and the impact that that can have on the synthesis of elements. What gives us hope is that we know we will be detecting thousands of these neutrinos in our detectors the next time a supernova goes off in our galaxy. So with my research, with the Fundamental Physics Directorate at SLAC, we hope to use this information to solve one of the great mysteries of our universe, the not so elementary origin of the elements. Thank you.
That was wonderful. I'm never going to look at ice cream the same way again now. Also, my favorite part of the slide was kaboom with 3 exclamation points. All right, our next trivia question. Researchers at SLAC use purified liquid xenon to search for mysterious dark matter particles in which state in the country? Do you want to say that louder? South Dakota. South Dakota. Is that the correct answer? It is South Dakota. Your prize is coming to you very shortly. All right, our next presenter is from the Biomaterials and Biomanufacturing. And the name of her presentation is Unlocking the Power of Plants. Please give it up for Jenny Only.
Can you believe that gas is $6 a gallon in California right now? I think we're all tired of paying so much money for something that we know is bad for the planet. We've got to open a new door and find a new way to make gas that is cheaper and more environmentally friendly. That's why in my lab, we're trying to turn plants into fuel, or more precisely, biofuel. And we can make so much more out of plants than just gas for cars. We can make jet fuel and other valuable chemicals. But we would especially like to use non-food plants so that we don't compete with food sources. Unfortunately, grass, wood, and agricultural waste are hard to work with because they're composed of strong fibers linked together by complex chemical bonds. The strongest fiber is called lignin. That's what makes wood so rigid. And in the biofuel production process, over half of the lignin is actually just thrown away because it's literally and metaphorically so hard to work with. But if we could open the bonds in fibers like lignin, we could use the smaller pieces to make biofuels. You can think of all those complex chemical bonds in plants like a bunch of locked doors, and we just need the right set of keys to open all of those doors. For us, the keys are made of enzymes which unlock chemical bonds. But matching the right key to the right locked door is complicated, and right now we can only unlock a few of these doors. To unlock all the doors, we need to discover some new enzymes. A lot of biofuel scientists are working on this problem, but the process is so slow because there's so many combinations of enzymes and chemical bonds. But what if we could take a shortcut? That's where my work comes in. Instead of testing the whole plant, which has a lot of component parts, in my research, test model compounds that are simplified versions of the chemical bonds in plants. Basically, I shrink down all the doors. And this way, I can test all the doors at once with every key in one small room, all at the same time, instead of walking from door to door. It saves a ton of time. I use a technique called mass spectrometry to examine those chemical bonds. And by examining them before and after treatment with enzyme, I can determine if a particular enzyme unlocked a particular chemical bond and how they did it. Recently, my team found several enzymes that unlock the bonds in lignin, that really tricky fiber that we usually just throw away. You could say that we opened the door to wood. It's not literally a wooden door, but I think you get the metaphor. Unlocking biofuels will open the door to lower gas prices and create a cleaner and safer environment for the next generation. Thank you.
She had me at California gas prices. All right, the next trivia question. What was Sandia National Labs called when it was part of Los Alamos? Ooh, I feel like we're really testing people, or they're all looking down on their phones. No cheating. Yes? X-Division. X-Division. Is that your final answer? That's his final answer. Does anyone else want to compete with that answer or support it with the same answer? That's not right. Someone else guess. I saw a hand up there, yes. Little Alamos National Lab. Points for creativity, but he was closer. Hand back there, yes? Sorry? Z as in Zeta? Z as in Zeta Division. That is correct, yes! Z Division. The questions only get harder from here. All right, I'm excited for our next contender. She works in the biosciences, and she's presenting on choosing the right road to aroma. Please give it up for Aparajita Srinivasan.
When was the last time you went to a movie night? Remember enjoying it with some popcorn, with a nutty roasted aroma wafting about. There are additives in your popcorn that enhance its flavor and aroma. Where do these additives come from? They can be made using chemical synthesis. But you don't want petrochemicals ending up on your plate, do you? They can also be extracted naturally from plant sources, but we need to extract from tons of plant materials to even get to 1% of these natural aroma compounds. Not sustainable. That's why at Berkeley Lab, I use microbes, engineering them to make more of these natural aroma compounds in a sustainable manner by feeding them just plant wastes. Let's get back to the movie night. What if I ask you to drive to the movie theater at Berkeley and the movie starts in an hour? What do? Okay, Google, get me on the fastest road to the movie theater. Now, Google predicts the best road out of all possible roads and gives you an estimated time of arrival, or the ETA. Likewise, I use computational models to predict the optimal pathway inside the microbial cell, leading to maximum production of these natural aroma compounds. I then test it out experimentally in the lab using synthetic biology tools. Do you think I'll end up with loads of these aroma compounds on the very first go? Here's a clue. How often do you expect to reach the movie theater at exactly the same time that Google predicted when you first started your journey? Expect some delays, take detours. So why? Because Google updates these ETAs based on a lot of conditions happening along your journey, like the road conditions, the number of vehicles on the road, regulating traffic lights. Google updates this and your ETA gets updated. Likewise, I use experimental data from the microbial cells at different levels, such as at the level of the genes, the proteins, and their regulation. We call this multi-omics analysis. I feed this data to my model to enable it to make even better predictions in the next iteration. This rational, model-guided microbial engineering not only helps me to make more of these natural aroma compounds, but also compounds that can potentially be used as jet fuels. So next time you enjoy your movie night with some popcorn, I hope you'll remember me and my microbes on the hunt for the right road to more natural aroma in a sustainable manner. Thank you.
I feel like I learned a lot about Google Maps right there. That was very informative. Thank you. All right, judges, I just want to do a quick check-in. How are we doing? How are you feeling right now? By show of emoji, that's how I express everything. Oh, we got dual hard eyes over there. Nice. Love. Crying, laughing. Nice. For real. For real. She's in this for real. Wonderful. All right, our next trivia question. Only 2 contestants on the Fox television show Are You Smarter Than a Fifth Grader went on to win the $1 million prize. Name the contestant that worked at Berkeley Lab. Mike, what do you, the answer is Mike Wither.
Can I answer if you don't have people?
Anyone else in the audience want to answer? Otherwise, all right. George Smith. There we go. Does anyone know by chance who the other person was? So George is a Nobel Prize winning scientist. And when you look at his Wikipedia page, it's like astrophysicist, Nobel laureate, and winner of Are You Smarter Than a Fifth Grader? It's all in the same sentence. Does anyone else know who the other person was to win Are You Smarter Than a Fifth Grader? Or what they did? It's a superintendent at a public school in Georgia. So that's very impressive. Nobel Prize winning physicist and a principal. Very, very fifth grader knowledge. All right, our next contender, this is from the Biosciences and Biotechnology Division. The presentation is called Genetically Modified Organisms, a Novel Solution or the Next Biothreat. Please give it up for Jennifer Klebeck.
Imagine you're in a Jeep in the middle of a rainforest. Behind you, you hear giant footsteps approaching. You look out the window and, oh no, it's a T-Rex! And then you wake up and you realize it was just a dream. Many of us may have had this nightmare after watching Jurassic Park. Thankfully, today, we cannot modify DNA to bring back dinosaurs, but we can modify the DNA of bacteria. Now, modifying the DNA of bacteria can be a good thing. We can make them produce medicines for humans or clean up oil spills in our oceans. The danger occurs when we release these genetically modified organisms, or GMOs, into the environment where they could become a biological threat instead of being beneficial. In my work, I'm developing strategies to prevent the Jurassic Park of bacteria from happening. Let me give you an example. Let's say a scientist modified bacteria so that their DNA produces a fertilizer. If a farmer took this GMO and mixed it with the soil, they'd expect to get higher yielding crops. A problem with this, though, is that these GMO bacteria, they're not alone in the soil. There are also native soil bacteria around as well. One biothreat is that the modified DNA could transfer from the GMO into the native soil bacteria. This is bad because now these native bacteria with the new DNA, they could produce too much fertilizer, which could harm our farmers' crops. To prevent these biothreats, I'm using a process called genetic entanglement. Using this novel technique, I can entangle my DNA with a toxin, so a single strand of DNA produces both the fertilizer and the toxin. The idea is now if the DNA transferred into the native bacteria, they would produce this toxin and be killed, protecting the natural ecosystem. Next, I tested to see if this actually works. What I did was to measure transfer of DNA into our native bacteria. When I measured the DNA without the toxin, I saw a high level of transfer. However, when I entangled the DNA with a toxin, I see this transfer is reduced by 100,000-fold. This shows genetic entanglement not only helps our farmers, it brings us closer to widely using GMO bacteria for human benefit safely, without those scary dinosaurs. Thank you.
For what it's worth, I feel like Hollywood would spend a lot of money to create a Jurassic Park of bacteria. So, all right, our next trivia question. Where is the Gemini planet imager located? Yes. Say that louder. Chile, is that correct? Yes, on the Gemini Observatory South Telescope in Chile. Congratulations. You got the country, that's close enough. All right, our next contender, he comes from the Mechanical Engineering Department, and his presentation is called X-ray Meets Supercritical Fluid. Please give it up for Ho-Yuan Lee.
Hi everyone. Okay. So every day I have to get a hot cup of water and start the new day with hot coffee. Usually in the kettle, water cannot be heated more than 100 degrees C. If we want to go beyond that, we need to add pressure. For example, if we put water in a pressure cooker, then we can easily go beyond 100 degrees C. And if we keep adding more and more pressure, then at some point, we would realize that the difference between liquid water and water steam, they disappear. This indicates that the temperature and pressure become so high such that water enters the supercritical state and becomes a supercritical fluid. This phenomena, the supercritical fluid, was first discovered and systematically studied 200 years ago. Nowadays, supercritical fluid has become an indispensable part in many industry applications. For example, supercritical carbon dioxide is widely used in power plants and oil extraction, and supercritical water has found many applications in biomass decomposition and chemical recycling. Even the decaffeinated coffee is made with supercritical water. Besides, currently scientists are actively searching for opportunities to use supercritical fluid as the reaction environment for green chemistry, and we hope that this may help us to save the environment. So all these supercritical applications makes the study of supercritical fluid supercritical. However, the study is not easy. As shown here, the temperature and pressure is very high there, and therefore, most of the commonly used technique cannot give us information with high enough resolution in space and time. This makes the study of the microscopic dynamics and structure of supercritical fluid very challenging. The game changer is the ultra-fast, ultra-bright hard X-ray pulse from the linear coherent light source at the SLAC National Accelerator Laboratory. Our research team comes from SLAC and Stanford University. We built a super stable beam splitter. With this beam splitter, we were able to take snapshots with a picosecond time resolution. And from these snapshots, we were for the first time to be able to learn how these molecules form a cluster in supercritical fluid. Hope that in the near future, we can learn more from these snapshots and becomes better to understand and utilize supercritical fluid. Thank you.
I feel like you know it's a science pitch slam when the walk-up music is just water gurgling onomatopoeia. All right, our next trivia question. Ernest Orlando Lawrence received the 1939 Nobel Prize in Physics. All right, we got a couple winners over here. You can raise your hand and they'll come deliver it for you. Great. Follow-up question. Do you know how much it weighs?
Look to you as well, because we won't see it.
We can go to the answer, Cyclotron. It actually weighs 27 tons. And that is the only fun fact I can give you because that's all I could remember. All right, let's move on to our next presentation. This comes from Applied Combustion Research. The name of the presentation is A Breath of Fresh Air. Please welcome Gustav Nierenstedt.
You thought I was wearing that mask for COVID, didn't you? No. I wear it against another threat, one that kills up to 7 million people globally each year, twice the number of COVID deaths at its peak in 2021. Do you know what I'm talking about? It's also the second largest contributor to climate change after CO2. Is it methane? Water? It's air pollution, soot particles, commonly emitted by engines. So how do we deal with a threat of this magnitude? I recommend electrification. With electric motors, soot is gone. But unfortunately, soot is mainly emitted by heavy transportation. Locomotives, ships, trucks, airplanes, vehicles that are near impossible to electrify. So then what? Well, I would use my magic wand, but I wasn't allowed to bring props here at the slam. Luckily, I have something almost as good, and it's no bigger than my thumbnail. We call it ducted fuel injection, DFI. And DFI was invented in 2015. It consists of several small ducts placed inside the engine, which enhances the fuel air mixing almost to perfection. I have done calculations, simulations, experiments, and they all show almost complete soot removal. Look at the picture here behind me. On your left, yellow, sooty, dirty flame. But on your right, a clean, beautiful blue flame with DFI. It honestly blew my mind that something so small could achieve this. Right now, I work on proving that DFI lasts for an engine's lifetime, and I believe it will be in production within 3 years, because as a double bonus, DFI can be retrofitted in existing engines while it works even better with renewable fuels. In my latest experiments, I used DFI as a baseline. And when I then changed to conventional combustion, soot skyrocketed by 1,300%. When my grandfather was young, he had to endure hardships that I can hardly imagine. But he had clean air. DFI is a perfect solution to ensure that we do not compromise air quality for prosperity. Our children deserve a breath of fresh air. Thank you.
Our next trivia question is, what year was Sandia, California established? Yep.
1948.
Judges, what do we think about that? Let's do an emoji. What do we think about that one? We got an question mark. Any back there? Yes. All right, I feel like we might need to challenge that's not what I have, but I don't know enough about Sandia, California to know that information. Do we have anyone who has the answer that's on the next slide? Yes. You're getting closer to the answer on the next slide. What was it? 1948. That's farther away. Colder. 57, very, very warm. 1956. You guys got that so quickly. It was established in 1956 in Livermore, California. Congratulations. You can raise your hand and we'll give you your prize. You will have to take up your 1945 with the sharks. Not my jurisdiction. All right, our next contender, this is in energy sciences. The name of the presentation is called The Shape of Water. Please welcome Sarah Gleason.
I'm in love with the shape of you.
When you were in elementary school, do you remember learning about the 3 main states of matter? There are solids that have a defined shape and volume, gases have neither of these, and you probably learned that liquids have a set volume but can flow and take the shape of their container. I'd like to challenge this conventional thinking about liquids and show that defining the shape of water can be harnessed with powerful results. This is an idea that's already found everywhere in nature, like the cells in your body, which are basically tiny liquid compartments given shape by membranes. What if we could design new materials to make membranes that could replicate the function of our cells? Imagine an artificial cell containing carefully shaped liquid compartments. The cell could move through your body and deliver a variety of different therapies just by rearranging its membrane structure, from releasing a drug to synthesizing a protein on demand. It's really exciting to think about the future of medicine this way. But one of the biggest challenges to achieving this is that current membrane technologies don't effectively adapt in dynamic environments like the body. What we need is a better understanding of how responsive materials can be used to give a shape to water that changes over time. This is where my research comes in. In my work at Berkeley Lab, I design thin layers of molecules called surfactants that form barriers at the interface between fluid phases. It's similar to how a water balloon is able to separate the liquid inside from its surroundings, except my membranes can be 1,000 times thinner than a human hair, and they can lock water into whatever shape I design it to be. In order to achieve those dynamic properties that are so important for artificial cells, I design my molecular barriers to have a specific lifetime. I add high-energy molecules as chemical fuel in the system. While the fuel is present, those balloon-like membranes are in place. But when the fuel tank runs empty, the balloon pops, allowing the liquid inside to reshape and react with its surroundings. By carefully controlling the chemistry, strength, and lifetime of these nanoscale membranes, I can engineer larger scale fluid systems that evolve over time. So by reshaping the way that we think about liquids, we're paving the way for future advances in artificial cells and more effective and versatile medical technologies. I think we can all agree that this is one idea that really holds water. Thank you.
That was much more educational than the movie, The Shape of Water. All right, our next trivia question. Which U.S. president signed the Department of Energy Organization Act, which brought together the Federal Energy Administration, Federal Power Commission, as well as other programs to create the Department of Energy we know today? Say that louder. This was Jimmy Earl Carter Jr. Congratulations. The real question, though, did you actually know that Earl was in his name? All right, our next contender, this is from the Materials Science Division. The name of the presentation is No Margin for Error, Designing Better Explosives. Please welcome Christopher Miller.
It tells a pretty dark story, though. You know, if you don't know, 99 Red Balloons actually tells a story of a world beset by nuclear war. Now, we've had nuclear weapons for, going on just about 80 years now. We have managed to avoid that fate. How? Maybe it's because we're all calm and rational people. Yeah, we've all been on social media. That is not always the case. No, make no mistake, the #1 deterrent to nuclear weapons is nuclear weapons. Mutually assured destruction. Terrible name, extraordinarily effective policy. But that policy only works if your weapons work. What if they didn't? What if the explosives you put into your weapons failed to detonate? This may not be a problem now, but we really can't afford to wait until it is. How do we design better, more reliable high explosives? My solution, microballoons. These are exactly what they sound like, miniature hollow glass beads that you mix into your explosive when you make it. Well, gee, how does that help? Excellent question. When your explosive gets impacted, these balloons can collapse in on themselves, potentially triggering the surrounding material. Okay, think of popping bubble wrap. Fun. Now imagine if that bubble wrap, instead of plastic, is made from a high-powered explosive. You have a pretty good idea of what I'm getting at. But I had to test this theory. So I ran a number of simulations using Livermore's very own high-performance computing clusters. Say that 10 times fast. Whereas a single experiment, it can take weeks, it can take months to set up. I'm able to run hundreds of these every single day. So what did I find? Well, when your balloons are small, your explosion is small. As your balloons get bigger, your explosion gets bigger. And when you make your microballoons even larger, your explosive potential actually drops. Turns out, too much of a good thing is a bad thing. There is in fact an optimal size to these microballoons we really knew nothing about. Thanks to my work, we can design around this in the future. Now, maybe you're sitting there thinking this is a pretty small detail, but don't forget the big picture here. If your explosive doesn't work, your weapon doesn't work. If your weapon doesn't work, your deterrent doesn't work. And if your deterrent doesn't work, maybe 99 red balloons stops being quite so hypothetical. But please, as you drive home tonight, don't stay up, don't worry about our nation's security. It is my mission, and really that of the entire lab, to ensure the reliability of our nation's nuclear stockpile. And hey, if you ask me, we are very good at what we do. Thank you.
I feel like we're all going to have 99 Luftballoons stuck in our head for the rest of the day. All right, our next trivia question. What year did Lawrence Livermore, Los Alamos, and Berkeley Lab join forces to start the Human Genome Initiative? What was that over there? 1980, 1980. Do we have any other, yes? 1990, close. It's in between those two.
So Kasha?
Sorry? 1992, that is not in between those two. Someone said 85, that is in between those two, but not the right year. 89, we're getting closer. Yes? 88. Not quite. Someone said something over here?
So Kasha, I just want to.
What did you say? 1987. Is that the correct answer? We're running out of numbers between that decade. The answer is 1987. I can spoil it for you. Congratulations. Wonderful process of elimination. All right, our final, oh, we need more time, they're saying. Oh, I see, okay. All right, well then I guess let's just, how's everyone's day going? I think this presentation, I think this entire event is extremely wonderful. I wish I had something like this when I was going through school, when I was in science communication. I do work as a science journalist, and I really like my job because every day and all day, I always get to talk to scientists, and I'm always learning new things. Like I learned that astrophysicists are very good spellers because they're constantly spelling all these really long, complicated words like heliopause, spectroscopy, insufficient funding. Did the judges, do I get an emoji score for that one? I get a love. I get a for real. LOL. Nice. I didn't get the winky face for this one though, so. There you go, 1987. All right, our final contender of the night. I like calling them contenders because this is kind of like a boxing match. All right. Our final contender comes from Fundamental Physics Directorate. The name of his presentation is What's the Matter with Antimatter? Please give it up for Brendan Bullard.
The gases is made of atoms. We call the collection of all these atoms matter. But if you're into science fiction, you may have encountered its sinister-sounding twin, antimatter. This mysterious substance, when combined with ordinary matter, completely annihilates into pure energy. If harnessed, antimatter could be used to power spaceships, or even build the ultimate doomsday device. While antimatter may sound futuristic, we actually already use it for things like medical imaging. The P in PET scan stands for positron, the antimatter version of the electron. Now, we know that antimatter is very rare in the universe today, but we believe the universe began with equal amounts of matter and antimatter. But if they were exactly balanced, then they would totally annihilate, and there would be no elements, no stars, no planets, and no us. So something happened shortly after the Big Bang that shifted this balance. For every billion antimatter particles, one was converted into ordinary matter. This small amount of matter that survived total annihilation went on to form all the stars and galaxies we see in the night sky. The open question is then, what happened shortly after the Big Bang that generated this matter-antimatter asymmetry? The best tool we have for answering questions like these is the Large Hadron Collider, the LHC. It smashes protons together at the speed of light, each time creating a mini Big Bang that we can study with particle detectors like the ATLAS experiment. In my research, I used the ATLAS experiment to try to understand the origin of the matter-antimatter asymmetry. My hunch is that it's intimately connected with a particle that we only just discovered 10 years ago, the Higgs boson. To find out if the Higgs is responsible for saving us from total annihilation, I'm searching for collision events producing not only one, but two Higgs bosons, an exceedingly rare process. In order to find enough of these super rare double Higgs events, we're going to turn the LHC up to 11. In the year 2029, the LHC will start colliding protons at rates never before encountered by a collider experiment. And all of those particles being produced will erode the detector from the inside out. So I'm rebuilding the very core of the ATLAS experiment at the SLAC National Accelerator Laboratory with better technology so that I can be strong enough to survive and precise enough to capture every one of those fleetingly rare double Higgs events. The third data-taking run of the LHC has just begun, and within the next decade, we'll be closer than ever to understanding the origin of the matter-antimatter asymmetry. Today, we stand at the beginning of a research program that will end a mystery about the very beginning. Thank you.
I think the part that stood out for me the most in that presentation was the phrase, "to save us from total annihilation." So thank you for your work. All right, our last trivia question. Which scientist has won the 2022 Klein Award for Coronavirus Vaccine and Protein Transporter Research? All right, this is not looking good for what our current news IQ is. Does anyone want to give a guess? Does anyone want to surreptitiously Google this? We can give you 2 mugs of candy. Oh, back there. Okay. Okay, you can at least try to make it look like you didn't Google it. All right, I guess because nobody else did that, you win. The answer is Cheng Cheng Fan. So congratulations on utilizing Google. All right, well, that is the end of our slam. Now our judges are going to deliberate, but before we do that, I want to bring all of our contestants up here, all of our finalists. They did wonderful work at each of their own labs. So everyone, please come up here. We'll give them one more round of applause, and we'll take a photo. This is when the rally towels are supposed to go. Yeah, there we go. And then next we'll bring up I believe there are some alumni from previous years, so we'll come up here and do a picture after them. Thank you very much.
1
If the judges need to get up to leave to deliberate, they can do so now. And then we'll bring up the alumni if there are.
Yeah, you let people to vote.
Oh, yeah. How do they do that?
It's on the slide behind you.
Oh, for the people's choice. Oh, okay. Is it? I don't turn it on. Oh, not yet. We'll go back to the other slide. And then now I would like to remind everyone to vote for the People's Choice Award, and we'll put up that slide again. Oh, you can go to the one before this. Can I do that? Oh, yeah, here we go. Oh, great. So go to bayarearesearchslam.org and vote for the People's Choice Award. bayarearesearchslam.org, the People's Choice Award. All right, now while we wait for the judges to decide on first place, second place winner, and we calculate who the People's Choice Award are, I was told that I also have to give a presentation in order to pass today. As I already told you, my name is Kasha Patel. I do science-themed comedy. I run a company called DC Science Comedy, where we actually specialize in science-themed jokes. I really enjoyed this event. Like I said, I am a science journalist. I write a lot about climate change, and I think that is actually very appropriate because my comedy career is a lot like climate change. It's pretty unbelievable, even though there's evidence of it occurring all around us. Part of my job is to help distinguish the difference between fact versus myth for the general public. So for example, fact, you can get an STD if a koala scratches you. Myth, your wife will believe you. I do enjoy my job because every day and all day I get to read a lot of studies from the Pew Research Center that said 80% of Americans think that science has actually improved their lives, their eating habits, and their overall happiness. Apparently, the other 20% were PhD students. I read another study that said, men are funnier than women, but it was written by a man. So I just thought he was joking the entire time. I was like, yeah, you're a real comedian. I actually, like Eric said, I did study chemistry. Where are my chemists at? Yeah, one proud chemist. That's great. I always love meeting another chemist because there is always an immediate bond. Thank you. Thank you. I know some people don't like chemistry wordplay, and I call those people physicists. So it's fine. Do we have physicists? Clap it up. Physicists. Yeah, it was really hard being a chemistry major because you got bullied a lot when you were younger, right? I mainly got bullied by physics majors because I always thought they were better than me, right? But then I learned that there's actually something called theoretical physics, which I didn't realize was just calculating all the ways you can die from a Final Destination movie. I also found out that theoretical physics is this field where, you all know, you just calculate what could happen, but you don't necessarily have to prove it. And I just wish I had more theoretical classes growing up. Like, I would have loved to have theoretical physical education. Like, yeah, I could tell you how many push-ups I could do, but never actually have to prove it. A lot of people, though, for physics in particular, chemistry a little bit, they find it hard, if they're not in the sciences, they find it hard to relate to. So I actually came up with a presentation called Everyday Physics by me, a chemistry major. I think it's very important to show how much physics is in our everyday lives. So I think one common application is the physics of public transportation. This is me on a bus. You can tell this is after pandemic because I'm happy to be on this bus. Now here's the situation. You have a smelly person, you have a millennial on opposite sides of you. And this is their radius of impact. Now, every stop, the smelly person moves 1 seat per stop. The millennial, who's talking really loud and bothering you, moves 1 seat every 2 stops. The question you have to answer is, where can you stand to avoid the millennial and the smelly? You have 4 stops to go. This is actually a pretty simple plug and chug equation. We know what our initial velocity is. What our time is for the smelly and the millennial, and when you calculate all that, you find out that the answer is grab a lift. That's your best scenario, grab a lift. The physics of cooking, that's a very popular one. Roughly how long will it take a chicken with a mass of 2.2 kilograms to cook? Remember that it takes 20 minutes to preheat. So again, we have to put them in common units. We get our grams. You have 98 minutes plus another 20 minutes because you have to remember to preheat. So in total, it's going to take you 2 hours to cook this chicken, which brings me to another equation that we can use instead. It's called taking my phone and deleting my only dating app to make room for my Grubhub app. I got so excited about this discovery that I actually tweeted this at Grubhub, and they responded by saying, because a sandwich won't ever break your heart. And I said, unless it's a Big Mac. Also, you can follow me on social media for more Grubhub interactions. I was a nerd growing up. Where my nerds at? Clap it up. Yeah. It seems odd to me that some people aren't clapping when they're at a nerd slam right now. That's incredible to me. I was a nerd growing up. I actually used to call my iPhone charger mitochondria because it was the powerhouse of my cell. Thank you, thank you, thank you, thank you. But being a nerd wasn't cool when we were young, right? Like now it's cool because like we own stuff. But back then it wasn't cool. So I tried doing something all the cool kids did. I decided to play a sport. I played ultimate frisbee. I played the position of treasurer. I did very well in Excel. I actually found out, though, that my mom's biggest worry for me in high school was that I was going to come home pregnant. My mom thought I was way more popular than what I actually was, because for fun, in high school, I created a Scrabble club. Yeah, the only members were me and the computer. So no, Mom, I'm not getting pregnant. You can't even spell pregnant on the Scrabble board. There's one too many letters, and the probability of you getting a P, a G, and 2 N's is 1 over 203,000. So things worked out for my mom. I did enjoy studying chemistry. I studied science growing up. Like I said, I write about it now. And I learned that one of the only real differences between being a frat boy and a scientist is just really good documentation. So we're going to play a game here. Are you guys excited to play a game? Great. It's going to happen anyways because we have to fill up time. This is the time fill. Okay, so I'm going to give you a scenario. You're going to tell me, was this done by a frat boy or a scientist? First scenario, sleeping with a dolphin. Clap it up if you think this was done by a scientist. Frat boy. Oh, very educated crowd. The answer is both, but only the scientist documented it. Second one, giving cocaine to a group of rats. Scientists. Frat boy. The answer are scientists, correct. Next scenario, giving cocaine to a group of rats and then playing Miles Davis. Scientists. Frat boy. All right, the answer was scientists and a group of rich white frat boys. And then the last scenario that I'll give you is putting blue food dye in a person's beer and seeing how they react. Scientists. Frat boy. The answer is me last night at a bar, so you're all wrong. Although I don't know what that says about me. Too many of you clap for frat boy. That's fine. I think my favorite scientist growing up was George Washington Carver. I think he's underestimated, as a prolific inventor, but he had a lot to him. And I think people overlook him because he's the only example of a man who gets less famous as you finish saying his name. Thank you. I know that a lot of people like talking about robots. Has become a lot. Clap it up if you do anything with AI in here. Oh, wonderful, wonderful. A lot of people like to tell me that robots are going to take over the world. Is that true? You don't think so. What kind of robot are you creating?
So I'm basically doing the applying artificial intelligence to high-speed network.
Oh, high-speed network. That sounds like some Terminator stuff. Okay. People tell me that, so I actually got a robot vacuum recently, and I was very excited, but people told me that I shouldn't have gotten one because when robots take over the world, you don't want to have one in your house. And it was weird because my robot vacuum actually knocked over my table, broke a glass, and then cleaned it up. And I was like, is this robot showing remorse? Out of all the Terminators, I got the empathetic one. I do think it's weird what scientists are creating robots to do, though. Like I heard that they're starting to make robots that can play soccer and dance salsa. And I'm thinking, are these scientists just assembling friends at this point? I don't get it. I do think that science fiction does have a lot of interesting depictions of robots, but a lot of people ask me, could that robot actually exist? And I get asked this question so much that I actually created another presentation. Does this robot exist? One of the most popular ones I kind of already alluded to was Skynet. Skynet is this entity that no matter how much you try and put it down, it just keeps coming back and back and just seems unkillable. We actually do have something like that. It is the Bachelor/Bachelorette series. Like, even during pandemic, it was still there. I don't understand. WALL-E, everyone loves WALL-E. He's adorable, and he just wants to make humans better. He just wants to clean up all the trash everywhere. And we actually do have a WALL-E, very inspiring. We do have a WALL-E version here on Earth in real life, and that is Marie Kondo. R2-D2. R2-D2, everybody loves R2-D2, just like so much fun. Clap it up if you like R2-D2. We saw some clapping there. R2-D2 is wonderful because he's just like this big package. He's just this fun in this small package, comedic relief. You could probably take him out and he won't really affect the plot line, right? We actually do have an R2-D2, and that is Danny DeVito. And then Westworld. Westworld has been very popular recently on HBO a few years ago. And Westworld is this world where you walk in and you can't really tell who is human and who is robot, because they all are kind of acting the same, and it's really hard to discern. And we actually do have a lot of Westworld around here in real life. They are CrossFit gyms. It's international. CrossFit gyms are international. Now, I would like to say that I did grow up in a place that wasn't very well known for their science. I actually feel the unknown demand of Indian female comics from West Virginia. Thank you. Thank you. Has anyone here been to West Virginia? Oh, wonderful. Did you like it? Who raised your hand? Did you like it? Thumbs up. You would give it a good emoji, a heart emoji. Wonderful. Not a lot of people say that sometimes. I think West Virginia is difficult because it gets a bad rep, right? But people don't realize all the really wonderful things about that state. Like we are ranked #1 with people with the highest cholesterol, which to me means West Virginians have the biggest hearts. Thank you. As you can imagine, there are not a lot of Indians in West Virginia. I was the only one in my high school. There used to be 2 of us, but then my brother graduated. And then for college, I did go to a small, historically Baptist university in North Carolina. And I remember that had like 10 Indians. And I remember walking on that campus and thinking, where did all of these Indians come from? And now I live in Washington, D.C., and I'm like, whoa, is this what India's like? This is amazing. My parents did instill a lot of education into me. They also taught me some unintentional things, like everything I learned about dating, I learned from my parents, who had an arranged marriage, which is why I was terrible at dating. Like I've never had a wedding before, whereas my parents called it a second date. I remember when I was starting to date, my mom decided to give me and my brother advice. She told my brother that he has to find a girl who can speak Hindi, cook Indian food, and who's a doctor. Yeah, I'm not even good enough to date my brother. The advice she gave me, she said, Kasha, don't pick a guy with bushy eyebrows, because he'll never trim those. Or Kasha, don't pick a guy with bad posture now, because imagine what that's going to be like in 50 years. Turns out she was describing my dad. I am very lucky. I actually did get engaged, or actually got married a few months ago. I forgot that we had the wedding. Thank you very much. Thank you. He is an accountant, which is fun. When we were engaged, he used to call me his fiance, and I would call him my fiancé. We did move in together. We've been learning a lot about each other. Like I learned that I really like fighting with him, which is great. Hear me out. He actually dropped out of law school, which means that he knows how to start an argument, but not how to win one. And I studied chemistry, so I'm really good at getting a reaction out of him. Thank you. I know there are physicists in the crowd, it's fine. I see her, before I got my job now as a journalist, I actually used to work for a small science startup called NASA. And it's always weird how you want to describe that, right? Because like if you want to be honest, you say you worked at NASA. If you want to be mysterious, I say I work for the government. And if I didn't want any follow-up questions, I said I worked for a travel agency. But it was really hard working there because no other government agency gets as much love. Like I've never seen someone walking around with a shirt that said DOE because because they liked what they did in the 60s. You didn't even wear your DOE shirt tonight, so. I do understand, though, why so many people like NASA. We were the first ones on the moon. Hey, you're wearing a NASA shirt. There we go. Not a DOE shirt. But I understand because NASA, we were the first ones on the moon. And scientists actually estimate that those footprints will last for 1 million years, which is the longest example of a man not cleaning up after himself. All right, we have our judges back. Have you come to a consensus? Do you have our little emojis? What's the, I guess, for real would be the consensus. A winky face, love. All right, we have a consensus. So do we have like music to bring them up to? Oh boy. All right, for the People's Choice Award, can I get a drum roll, please? Cool. Please give it up for Jennifer Klebeck. Congratulations. Okay, great. And then he'll take a picture there. All right, for our second place winner, with the presentation entitled Genetically Modified Organisms, a Novel Solution or the Next Biothreat, please give it up again for Jennifer Klebeck. I could have had you stay, but this is more exciting. All right, and now for our first place winner. Drum roll, please. Please welcome to the stage Brendan Bullard for his presentation, What's the Matter with Antimatter? Congratulations. All right, and now for the big trophy that someone gets to keep for exactly 1 year, I would like to call up our director, Pat Falcone, and our 3 finalists from Lawrence Livermore to accept the trophy. Congratulations to Lawrence Livermore. Oh, so right? Yeah, all 3 of you take a picture, right? Okay. Yeah. So we can get the 3 finalists from Lawrence Livermore. Sorry, my instructions were not very clear. Congratulations! And I would like to say thank you again to everyone that was involved. Give it up for all of our judges. Wonderful job. Great judging, great emojiing. Show us your last emoji for the night. How did you feel about it? Put up your last emoji for the night. We spent money on them, so we have to use them. That's pretty much it. I feel like I underutilized them all night. I'm so sorry. They can hold them around for cocktail hour as well. Please give it up for the Bar Slam committee staff from all the centers, the Information Technology Solutions, Technology Information Department, And this concludes another fantastic year, and now we have social hour, food, and drink. So welcome us in socializing. Again, congratulations to all the contenders and the finalists and all of you for celebrating this wonderful day of science. Thank you very much.